All right, it's time for some more calculus. This is actually still just pre-calculus review. We are solving for x here. We have an exponential equation. 8x minus 11 is equal to 38. Our goal is to get x by itself. We often will try and do different tasks because we either don't quite understand what we're doing or we just try and get ahead of ourselves. So one thing that I want to stress is if you were to solve this, not solve this equation, but try and evaluate this equation, that'll kind of help you set up your steps. So that's something that you want to go through. Don't speed through these. If you were to forget about the 38, pretend that 38 isn't even there, and I asked you to evaluate this if x equaled, I don't know, 5. Well, what would the steps be that you would do? Obviously, first you plug in 5. Then you would first do the exponent. You would do 8 to the 5th power. Then after you did the exponent, you would subtract. Well, you're solving this equation. So when you solve an equation, it's the opposite operation in the opposite order. So you need to deal with the subtracting of the 11 first when this thing equals 38. So we're going to deal with that subtracting 11 first by adding 11 to both sides. That gets rid of this. You're left with 8 raised to the x power, and that's going to equal 49. Now you have to deal with the exponent. Now you could try and take the x root, but what's the x root of 49? That's not a number. That's not going to get you anywhere. You don't want x to be in your root at all. That's not going to help you at all. What you need to do is you need to move that exponent. There's only one way that an exponent can move in an equation and not be there anymore, and that's through a logarithm. Any logarithm will do. It does not matter what logarithm you're going to use. Whether you use log base 10, which is just log, whether you use natural log, which is base e, you could do log base 8. But in these problems, I want an actual estimate. I want to know what the decimal estimate is, not just the exact answer. So if you do what you were probably taught in your pre-calculus or your integrated 3 or algebra 2 classes, you were probably taught to take the log with the base of whatever your base is. Since we are base 8, you were probably told to do this. And whatever you do to one side, you got to do to the other. And then you learned your pre-calculus teacher, your algebra teacher, algebra 2 teacher, however you had, gave you some instruction on what the log base 8 of 8 to the x power is. There is a rule, a property that we have with logarithms. It's how logarithms work. The fact that if the base, this little 8 here, matches this 8 here, then all of this cancels out, and you're simply left with the exponent as x. Well, that's kind of magical. And in math, there is no magic. There is no waving of the magic wand and poof, something happens. So I don't like having that rationale and just leaving it be. I don't want you to just learn a process. I want you to know what it is that you're doing. So if I put this problem off to the side and simply look at logarithms in general, and so what a logarithm is another way to write an exponent. If you have a base b and a power and exponent p, and you work it out and it equals some number n, well, by definition, another way to write that is log base b of n equals p. And so what you have over here, you have log base 8 of 8 to the x. So if you look at that, that's like this portion right here. You have log base 8 of something of 8 to the x power, and they're asking what the power is. Well, look at it. What's the power? The power is x. Notice that's what it equals. It equals p. So that's really what's going on there. You're really applying logarithm rules of what a logarithm means that you may or may not have really locked in from your pre-calculus class. Understand that the log base 8 of 8 does indeed equal x. But I don't even like doing that. I don't like doing log base 8 or log base 12 or log base whatever simply because our next step, what this is going to work out to be, is this indeed does end up equaling x, and so x ends up equaling the log base 8 of 49. So then my question is, how do you evaluate that? Well, some of your calculators nowadays will actually do log base 8, but a lot of calculators don't. And so how are you going to evaluate log base 8 of 49? You're saying, oh, change a base formula. You're absolutely right, change a base formula. What's a change of base formula? I forgot, Mr. Krueger. Exactly. So I don't like doing that because you might not know the change of base formula. So I don't do log base 8. Instead, every time that I do a log, I do the natural log, no matter what. Okay, you can do any logarithm that you want. I do natural log simply because my calculator has that button. If my calculator had log base 8, then I would log base 8 everything. But my calculator only has 2 logarithms guaranteed, log base 10, which is just log, and natural log. So I'm going to do the natural log of both sides. Now, you are not multiplying by natural log. Do not say that. I will correct you every time. You do not multiplying by natural log is like multiplying by a plus sign. You don't multiply by plus signs. You don't multiply by any operation. You are taking the natural log because the logarithm is its own operation. In doing so, this property, we have a property with logarithms. Going off to the side here again, we have a property with logarithms that says if you have the logarithm, any logarithm at all, I'm going to use natural log, if you have the natural log of some base to some power, then that's equal to taking that power, bringing it down in front of the logarithm as a constant multiplier. That's a fact that we have from logarithms. That's something that you definitely want to know and need to know. And that fact will help you with this problem. So we have the natural log of 8 raised to the x power, the natural log of b raised to a p power. So what that means is the power can jump down in front and become a multiplier of your logarithm. This is how we move powers of x to no longer be a power. X now is simply a multiplier. There's no more exponents. And so I'm going to get rid of this rule that we just used so that way we can finish the problem. And so now that I've got x times the natural log of 8 equals the natural log of 49, I can easily solve for x. See, the natural log of 8 is a number. I can punch that on my calculator. The natural log of 49, also a number. I can punch that on my calculator. I can divide because I want to get rid of the natural log of 8, and dividing would be the opposite. And so I end up with x is equal to the natural log of 49 divided by the natural log of 8, which, hey, that happens to be the change of base formula that I mentioned about a minute ago. And this I can just punch on my calculator. I punch on my calculator the natural log of 49, I punch on my calculator the natural log of 8, and I push divide and equals, and that should equal, rounded to the nearest hundredth, 1.87. So I don't care what logarithm you do. If your calculator can handle log base 8, then you can do log base 8. You should get this as the same answer. If your calculator doesn't, then you definitely want to take this path, because then your calculator will be able to evaluate the natural log and you'll be good to go. Does not matter to me. You just need to understand the process, because not only am I going to ask you to do this, but I could ask you at any step along the way, why did you do something? Why did you take the natural log of both sides? I took the natural log of both sides because I needed this x that's here in the exponent to move down here as a multiplier, and the only way to do that is to do a logarithm of some sort. So it's important that you understand why you're doing what you're doing, not just doing it.